afternoon, everybody. Thanks for your time today. I want to talk about where we're going with Layer 2. Now, everybody seems to say, and I agree, that our mission should be to onboard the next billion users. That is easy to say, but not so easy to do. Many people who have tried to do it have not succeeded. But I want to talk about what we need to do as a community to bring the Ethereum stack to the next billion users. And our approach has to start with this notion of alignment. And I think Vitalik's answer to the question about alignment is a very good one. But ultimately, to me, what it comes down to is aligning with our users. Because if we all align with our users, then we will be aligned with each other. And by meeting the needs of our users, we'll be able to actually attract that billion users online. So I think we should always be thinking, what is it that our users need and want, and how can we provide it? And if that's our North Star, then I think we have the best chance of getting to that billion. Now, I want to talk about 6 big moves that Ethereum either is making or will be making in order to get to that point. 6 important areas of emphasis. And that'll basically be the framework for this talk. Big move number 1 is to build in layers. This is something Ethereum is already doing. And here we can learn and have learned an important lesson from the most successful protocol in all of human history, namely TCP/IP, right? So TCP/IP basically works in layers, and by doing that, it achieves a couple of really important things. One is it gives a degree of modularity to the design so that it can adapt more easily, and each layer can focus on doing one thing and doing it very well. But also, by building in layers, you notice that that stack of layers is not just a line, it's a tree. So by building in layers, we can have variety and diversity at each layer, and that is really important for the strength of the ecosystem, both to meet different needs and also to experiment with different approaches. Vitalik caught on to this very early, unsurprisingly, and this is really what the roll-up-centric roadmap is about. It's about the idea that the Ethereum should be a stack, and that stack should be built in layers. Well, how's it going? It's going pretty well. Layer 2 and Layer 3 together, if you look at what throughput they've been providing, and you measure that in units of Ethereums, what you can see is, on a typical day, Layer 2 and 3 together is about 30 times the TPS of L1, about 80x the gas used, about 40x the call data, and there are roughly 100 Layer 2 and Layer 3 chains. So to illustrate that, let me show you a simple bar graph here, and this is to scale, showing the amount of gas used on a typical day on L1, L2, and L3. And many people are surprised that the L1 bar is about 1.5%, but also that the L3 bar is about as big as the L2 bar. So if you ask, what has the L2 roadmap, the roll-up-centric roadmap, been successful? I think it has, because it's taken us from this tiny bar at the bottom to now having to change the scale to fit onto the scale everything that's happening. So that's been a big success. But how do we take this even further? Well, in order to take it even further, we can move to the second big move, which is to connect everything. And so we get to this topic of L2 and L3 interoperation, which is one of the really hot topics of discussion in the community these days. Now, it's important to connect everything, but it's important how we connect everything, because there are many different ways at the technical level we can manage and control the interoperation. And the choices that we make here are really important for how and whether we can provide what our users need. Now, in terms of how we can do interoperation, again, I think we can learn a lot from the internet, from how the internet does interoperation. Again, the most successful interoperable protocol in all of human history. And internet interoperability really, I think, is built around these 5 principles. 1, focus on being fast as you reasonably can, given the constraints you have. 2nd, to be standards-based. Those things that you can standardize, especially things like naming and data formats, you should standardize. And there's work going on in the Ethereum stack and the Ethereum community to do that. 3rd, interoperation on the internet is asynchronous, meaning that when 2 boxes interact, when 2 components interact, they don't stop and wait for each other. because that other component might be slow, or indeed it might not respond at all. Notice that next, fault tolerant. The idea that in interacting with some component, you're able to deal with the case where it fails or doesn't respond. You design with that in mind. And you're constantly thinking about, well, what happens if the other component is not there? How am I going to cope? How can I keep serving the user? And then finally, security conscious, to think about, maybe the other component that you're interacting with might be compromised. What are the consequences of that? Those last three, asynchronous, fault tolerant, and security conscious, it's tempting to try to sweep them away under the rug. But in fact, I think we can learn something really important from the internet, which is even two boxes in a data center that are just centimeters apart, managed, controlled, and programmed by the same parties, even those boxes interact with each other asynchronously and in a fault-tolerant way. And so I think there's really deep wisdom in designing in that way. Now, when we talk about interoperation, there's kind of two different approaches that people take to L2, L3 interop. One of them is sort of chain clusters approach, where things are tightly coupled. You have the same governance, you have the same infrastructure, and you have tight constraints on what software you can run and how on all of these boxes to try to get them to be essentially identical in the hopes that you can get some advantage in speed by doing that. So that certainly is one approach, and there are people who are going in that direction, trying to get interoperation by forcing uniformity. But I think a better model is a model that's more like the internet. I mean, there are uses for the tightly coupled model. That's what's used, say, on the internet within a single data center. But if you're talking about interacting more broadly, I think thinking about a more loosely coupled model of interoperation. And that's consistent with this idea of asynchronous, fault-tolerant, and security-conscious. And I think this is where we need to focus on going, because ultimately, this is the approach that will give us a more robust and more practical system. Big move number 3, developers. And of course, we have to show this. So what does that mean? What do developers need? What do they want to be as useful and productive as possible? I would argue that what they want is really three main things. One is to be able to use familiar, standard, and battle-tested tools for programming. That means programming languages, it means tools and debuggers and fuzz testers and all of those sorts of things. Second, they want something that runs fast. And third, they want an environment where different smart contracts are fully composable, right? That's really the big strength of why we're on a blockchain, right? Is so that a programmable blockchain is so that you can get these things to work together. So in the Arbitrum stack, our approach to this is stylus, and the idea of the multi-VM. And that is, rather than having just a single virtual machine, a single way of deploying programs, instead the multi-VM approach says we can have a single execution environment that has EVM in it and a WebAssembly VM. And we can build that in such a way that they are fully composable in the way that programmers want. This gives you the benefit of being able to run EVM code if you want, to being able to write smart contracts in Rust or C++, run them in a fully composable way on the same chain. Not separate silos, but a single unified composable environment. I think this is a big step forward, and we're seeing other teams starting to work in this direction as well. Big move number 4 is to make it fast, but make it fast for real. And that means don't cook up a sort of fake benchmark so that you can have a giant TPS number to quote. Really focusing on the factors that limit performance in real life. That is, we want to understand what happens when we're running on a real chain, on real equipment, and with a real workload of lots of different diverse contracts and transactions on a chain that has a big state and a long history. This is the world that chains actually execute in. So how can we get to the point where we can push performance to the limit, but in a way that's realistic and focusing on the thing that, again, really matters for users and developers, instead of just trying to make a glitzy number that we can never really back up? Okay, so I think there are basically five approaches that are going on and being worked on in the community to get there. And I want to start with the first one, which is benchmarks. This is certainly outside of our community. The development of benchmarks has been really important, finding standardized ways to measure realistic performance. Both standardized and realistic are important here, right? Standardized because you want to be able to compare in a fair apples-to-apples way across different systems, and as well as you experiment with different approaches to design in your single system to be able to have a strong and valid comparison. And realistic performance also is important, so that you're testing in an environment that is as close to realism as possible, so that the numbers you get actually are a good predictor of how fast something will go. Second, faster execution. People are working on developing faster VMs, working on things like more efficient database representations to get better performance out of the same hardware. Third is the use of parallelism. And this in particular, I think, means finding parallelism that exists naturally already in the workload. Don't make developers worry about parallelism. Instead, just discover, well, we can run this transaction and that transaction at the same time because they're non-interfering. Discover that, take advantage of it, and make sure that your gas pricing and gas limits system is appropriately dealing with that so that you can have fearless parallelism for developers. Fourth, resource pricing. Now, we know that today, as soon as one resource on a node hits a bottleneck, you slow down and raise the price of all of the resources that are needed to execute that chain. We can do better than that. By having more accurate, more nuanced gas pricing, we can make sure that we make better use of the capacity of the ordinary nodes that we want to run our chain on, while at the same time remaining safe. I think there's really significant improvements in throughput available just by being smarter about how we track and price resources on the same hardware. And then finally, sharding. In the cases where you need it, to get horizontal scaling with less friction, by simply taking a chain and dividing it into a set of very closely coupled subchains. Now, that's not for everyone because there is not zero friction in interacting across those shards. But in cases where it's needed, this, I think, will be also a valuable tool. So a lot of things going on to try to make it fast. Big move number 5 is technical decentralization. And all of the major L2, L3 stacks have gone some distance down this road to decentralization, but we need to keep doing this to make sure that at a technical level, our systems are decentralized. So what does decentralization mean? Well, it means that actual power is dispersed. So to give you a couple examples from the Arbitrum stack, one of them that is upcoming soon for the DAO's consideration is Bold, which is a new dispute resolution protocol, which is the first and only fully secure fraud-proof system that has these characteristics. It's resilient against up to 7 days of censorship on the Ethereum chain. It has a fixed completion time no matter how many adversarial stakes are there. Bold will be able to resolve any disagreement with a fixed limited completion time. It allows honest parties to pool their stakes. So if you're a participant and you don't have enough funds to stake, you can find a whole bunch of other people, and they can trustlessly combine their stakes into a single pooled stake. And once you come up with one stake from across all of the honest parties in this shared way, you're good to go, and you can guarantee the safety of the chain. And it doesn't rely on a Security Council veto mechanism as part of its core security model. That is, if the Arbitrum Security Council goes away and does nothing, the system is still secure. The only purpose of the Security Council is to deal with the critical vulnerability. And the guarantee after this is in place is that any one user with their ordinary laptop can enforce safety and progress of the chain. That's possible, of course, only possible because we have L1 underneath us providing that core of security. But this is a really powerful security guarantee. I want to talk as well about sequencing, because decentralizing the sequencing function will be, for the Arbitrum stack at least, the very last step in technical decentralization. There's a lot to like about the current first-come, first-served model of sequencing. It has all these nice properties I've listed here, but there are two properties at the bottom that it doesn't currently have. One is that it doesn't currently internalize MEV value for the chain, and two is that it's not currently decentralized. It relies on a centralized sequencer, which, to be clear, is not trusted for the safety or liveness of the chain. It's only trusted to report which transactions have arrived and in what order. But we'd like that to be decentralized. So in terms of capturing revenue, there are a bunch of different approaches. Some systems are experimenting with priority gas auction. In the Arbitrum stack, the one we like is time boost, which basically involves creating an express lane at the first come, first served sequencer and giving a time advantage to a party who wins an exclusive license by winning an auction, giving them an exclusive time advantage over a 1 minute period. The idea here is to capture MEV revenue for the chain in this auction while doing as little, while maintaining the very fast block times and protection against front running and other good properties of this system. And critically, this can be done in a decentralized way. So this gives you internalized MEV value for the chain. You can also decentralize the sequencer, and that's an important thing to do. There's an ongoing research project in the Arbitrum stack between off-chain labs and Espresso systems to move to a committee-based sequencing scheme, so that you have a committee of sequencers, and provided that some suitable majority of them are honest, the behavior will be just like an honest centralized sequencer. So you get the nice properties of honest centralized sequencing, but without having to trust any particular party. Okay, so that gets you to the decentralized stage. And at least for Arbitrum, once Bold has been deployed, assuming the DAO approves it, and once this sequencer decentralization step is done, then the technical decentralization roadmap is finished. Other stacks as well are working on trying to get to the end of their decentralization roadmaps. But I want to talk finally about big move number 6, which is decentralized control. And here I think we can again look to the story of the internet. And I want to start with this famous essay written by John Perry Barlow in 1996 called The Declaration of Independence of Cyberspace, which explained that cyberspace was this new area and government could have no influence there, big companies could have no influence there. This was the birth of freedom for all of humanity forever, basically. Well, so that was 1996. Last week, we had Cory Doctorow, who is in some ways a kind of intellectual descendant of Barlow's thinking, wrote this. After about 10 seconds of sheer joy, what we got was all new gatekeepers who were at least as bad and even more powerful than the old ones. And the net became basically 5 giant websites, each filled with screenshots of the other 4. Right? So if we look at what has happened in sort of the Web 2 space, this original idea that it would be fully decentralized and not subject to the control of powerful entities, that didn't turn out. So what happened? I think what happened was that the community, that community lost sight of what decentralization really means. Decentralization is more than just a right on paper to participate. What it means is that power is truly dispersed to the community. The question is not who has a on paper right to participate. The question is who holds the power. So when we talk about decentralizing governance of L2s and L3s, I want to sort of draw a distinction between a phrase which I promise was already on my slide before a very interesting talk with the same title happened yesterday or the day before, decentralization theater. Decentralization theater is where you go through the motions and say the words, but you don't do it. There's pretty words about community, but your system's really, really custodial. DAO votes are just advisory. A multi-sig action is part of the plan and not just an emergency backup. And you have a theoretical right to participate, but you lack real power. True decentralization means you have an active, independent community. The DAO holds the master keys. When the DAO votes, it's not just a polite request to some multi-sig controlled by insiders to do something. The DAO's votes directly cause action on-chain. The Security Council, if there is one, is chosen by the DAO, and anyone can run a node or validator, and stakes can be pooled. I think that's true decentralization of power. So with those 6 moves, I think we can align ourselves with users and get to that next billion users. The future of L2, I think, is the future of Ethereum and vice versa. We are a unified Ethereum stack. We're not pushing and pulling against each other, or shouldn't be. And finally, the principle I'd like you all to remember is that we should all be trying to maintain in the L2 and L3 space is that if it's your chain, it should be your rules. Thanks. And we have some time, I think, for questions.
Absolutely. Let's give our speaker a nice big round of applause. Can I just say, as a former lecturer myself, I recognize when there's another educator on stage. Clear slides, great presentation, straight to the point. Let's go right to our questions. Ladies and gentlemen, first one on the screen. When will Arbitrum become a ZK rollup?
The answer to that is when the cost and practicality of ZK proving at the scale that Arbitrum needs is there. My view on ZK versus optimistic is that if we switched Arbitrum to be a ZK rollup tomorrow, our users wouldn't really notice. Optimistic versus ZK has very little effect on user experience.
Yep.
ZK rollup has some technical advantages. Our team has been working really aggressively at looking at ZK proving technologies and working with teams, but in my view, it's not really time to do that yet. That time will come. I gave a talk at the BAS conference at Columbia a couple months ago. It's available online, about an approach to doing this. I think actually the end game is a combination of optimistic and ZK proving, where you can get the best of both worlds.
All right, thank you very much for the answer. Fantastic.
Yep.
Why WASM and not RISC-V?
Why WASM and not RISC-V? There's a bunch of reasons. One is that fundamentally it's because WASM is designed for this type of application. WASM is designed for, it's type safe by nature. You can safety check WASM code statically at load time, and then you get very strong safety properties when you do that. That's number one. Number two is that WASM was designed not only with not only as an instruction set, but WASM was designed with fast execution in mind. And there's been a tremendous amount of effort to make fast execution engines for WASM, because that's built into browsers, it's built into consumer software. And so it's a much more mature, the execution of WASM efficiently is much more mature, and the tools for making sure that you do it efficiently are much more mature. And so we settled on WASM early, and I still think it's the right choice.
Yep, excellent answer. Moving on, we got a time for maybe three more. What do you think about synchronous composability between different L2s?
So I think you can aim for synchronous composability, but I actually think that here, this is a place where we can learn a lesson from the internet. Remember what I talked about before, how those two blade servers that are a centimeter from each other in the same data center still interact asynchronously because it's a more robust way to interact. I think the notion that one chain should stop and wait for another is something that we should question. You could do synchronous composability. I think there's a real cost in throughput of having one chain stop and wait for another. If you just rename synchronous as stop and wait composability, I think it becomes clearer why you might not want it.
Fantastic. People love that answer as well. And let's go to the next question at the top. How can we avoid different L2 ecosystems such as Arbitrum, Optimism, etc., becoming silos of data and value? Great question.
Yeah, it is a great question. It's a super important question and one that a lot of folks are working on. And the answer is basically that story about L2 interop. What we need is a set of open standards and open mechanisms for interoperation, right? Rather than focusing on how can I do great interop within my silo or within my tech stack, we need to figure out how we can have an Ethereum-wide interoperation framework. Not just data format standards, but also standards for mechanisms and what guarantees that these systems provide to each other. That's not easy to do, but I think we can do it. It's a really active topic for our research team, and really eager to work with teams across the sector on making this available for everyone.
All right, we got 20 seconds. Let's see if we can finish one question for the final. How can you claim Bold is decentralized if bond size is 3,600 ETH?
My answer is partly spicy and partly not. My spicy answer is that you could make it smaller, but you would be sacrificing security. And so I think that's necessary. But I think most importantly, the fact that you can pool stakes is critical here. It's not 3,600 from one party. It's 3,600 in total from all of the honest parties. Trustless stake pooling is key to making this work. You could make the stakes smaller.